All right, ladies and gentlemen, welcome back for another session. Today we are going to be focusing on congruent polygons, but specifically we are going to use these parts of polygons in algebraic equations as a means to solve for missing sides and angles. So remember, so far what we've talked about is that if two figures are going to be congruent, that concludes, or that is because that all of the corresponding parts are congruent to each other. We also talked about the concept that order truly matters. Order matters because you are specifically saying which parts match up with what endpoints to what endpoints, what angles to what angles. So we're going to use that in some algebraic expressions here. In the diagram, the two following figures that we have, these two quadrilaterals, are in fact congruent to one another. We want to know what find the value of x is first and foremost. So let's go ahead and take a look at where x is. Well, we see an x here in the angle Q, but we also see the x here in the side QR. So the question is, are we going to use both of them? Are we going to use one of them? Which one do we use? And how do we utilize it to solve for x? Well, let's think about this. If I want to use 6y plus x angle Q, do we notice an issue there? Well, hopefully you notice that there's both a y and an x, two variables in the same expression. That usually causes a little bit of reservation for us just because it makes it a little bit more challenging. So what about using the one that only has a single variable of x? So let's think about this for a sec. QR, the segment QR matches up with what segment? It is congruent to what segment in our other quadrilateral? Well, Q to R matches with F to G. F to G. So if that is the case, both these sides are equal to one another. So I set 2x minus 4 equal to 12. We see that 2x equals 16. And of course, x equals 8. All right. What about when we find a value of y? Well, now, remember how this used to be two variables? Now I know what x is. X is 8. So let's make our life a little bit easier and go ahead and substitute that in there. So now I can utilize the fact that Q, angle Q, matches on up with what angle? Well, Q matches up with F, right? Q and F match up together. So it's then going to be our responsibility to say that angle Q is congruent to angle F. And now we go ahead and see here, and again, angle Q matches up, Q matches with F. That's how we got that, right? They're congruent, order matters. So now we see that 6y plus 8 equals 68 for F. Subtract 8, 6y equals 60, and of course y ends up being 10 after the division. So I'm hoping that helped us to identify some characteristics of corresponding figures and also how we can tie in some algebraic equations into solving for missing sides and angles.